All right, so we know how to add, multiply, subtract polynomials. There is one big missing operation from that, division. It's a bit of a long story. So we're going to start just simply using it as a tool to factor polynomials. But later on, dividing by polynomials leads to a new class of functions called rational functions. We're not quite ready to talk about those yet. They're pretty cool. But for now, it's just a way of getting from one form of a polynomial to sort of a different form. So I have carefully chosen a polynomial that has a nice factor. So we will hopefully see that. If I can, oops. So here's the polynomial, x cubed minus 2x squared minus 5x plus 6. And let's just say that I tell you that 1, 0 is x, 1, 0 is, I guess it would be minus, no, plus 3 is x equals 3. Okay? So I've given you one piece of information. What can you do with that information? Well, so this implies factor of x plus 3. So this thing is going to be x plus 3 times something. X squared, x, right? So there's an x squared term, an x term, a constant term, and we need to find the coefficients. All right, so first, I guess I can do it the sort of fill in the boxes method. So what we need is x and 3, and then there's sort of like a x squared x in a constant term, and let me just, right, so our goal is to fill in those numbers. Oops. So x times x squared, well, we know that that's x cubed. And, well, yeah, so I should write this down. So what do we know already? We know that x cubed and 6, we've got those two things. And then we know that these guys, those two, they're the x squared terms, and so they'll sum up to minus 2x squared, and these guys will sum up to minus 5x, right? The other two we know. So 3 times something is 6, so that something is 2. And the x squared is 1. And so now we have 3x squared here, right? And, oopsies, sorry. X equals 3 factors x minus 3. Jeez. This is the problem with these polynomials. You're always flipping between two different signs for the same number. Very easy to, I mean, I have it written down, and I still, whatever. Anyway, so this is a minus 3. Minus 3x squared. So how do you get from minus 3x squared to minus 2x squared? You add an x squared. So you need this to be x squared, and that should be 1. let's see, this was supposed to be 2x, and then this is minus 3x. Oh, oops, I need minus 2 here. There we go. Yeah, because that was to get to the plus 6, and now I have a minus 3, so that's minus 2, and minus 2 minus 3x minus 5x. Notice that I have, as I can fill in pieces starting at the top and go work my way down to the bottom, and then that bottom is a check to see whether I've kind of made a route that makes sense, right? So that's cool. So basically what I've just done is computed out this factored form. Awesome. Now it's a quadratic, and so we can definitely get those factors, but I don't care about that. At least not right now. So that's fine, that kind of grid format. And to be honest, you could actually, I'm pretty sure you could do that with all the possible polynomial division problems. You've got a target polynomial, you've got one that you're dividing by, and you kind of know the degrees that you're going to have, and you just kind of fill in the blanks. Might be a little tedious. So here is another method, and I'll give a third method in a different video, which is probably the one you want to go with. But this is, well, long division. And everybody loves long division. All right, so the factor is, oops, just clear that off. Okay, so the factor is x minus 3, and we're dividing into x cubed minus 2x squared minus 5x plus 6. All right. So one of the reasons to ponder this long division of polynomials is it kind of hopefully makes a little bit more sense of the long division of numbers, which is always everyone's favorite topic. All right. So what are we trying to do here? We're trying to do, we're trying to multiply by a new polynomial such that when you do that, you get this long polynomial. So what does that mean? And you might see a resemblance to this in the bit of the grid, but so basically we need an x cubed term coming from this, and so x squared times x gives us that, so that's x cubed, so you just multiply the x squared times x minus 3, and the x squared times x is x cubed, and then you get minus 3x squared, and then you want to subtract it, because now we've matched it, and so you get minus x cubed plus 3x squared, so it's x squared, and then this is your new polynomial. So at this point, let me just try to write this over here somewhere, somehow. What I've just said is x minus 3 times x squared plus x squared minus 5x plus 6 is equal to our polynomial. Okay, so that's what I've just said. So if you multiply out x minus 3 times x squared, you will get x cubed minus 3x squared minus 3x squared plus x squared is minus 2x squared. All right, so that's literally what I've done. I just don't quite entirely write it that way. And now what's next? I need to cancel out that x squared, so that means multiplying by x squared minus 3x. Now I subtract that, so that cancels, and that becomes 8x plus 6. Nope. Nope, 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 nope. Nope, 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 nope. Yep, there we go. minus times minus 3 is plus 3, plus 3 minus 5 is minus 2x. All right, and now for our final thing is doing multiplying by minus 2 to cancel off that other thing, and notice that we have nothing remaining when we subtract that. And so this is saying that x minus 3 times x squared plus x minus 2 is equal to x cubed minus 2x squared minus 5x plus 6. All right? And you can multiply that out. You would use a grid like I just did before, only this time you'd know the outer parts and you'd be just filling in the inner parts. Or you can distribute, or however you like to multiply polynomials. It's all good. Now, let me just show you over in Wolfram Alpha that it can do these things for you. So as you practice, and practicing is a great way to actually get good at this if you care to do so. Just type it in like so, then divide by x minus 3, like so, and wait a little bit, and quotient and remainder. So x squared plus x minus 2, perfect, times x minus 3, and then there's no remainder. Excellent. So that's Wolfram Alpha. And, well, I guess while we'll do this, let me do another one in terms of having a remainder. We can see how that might look like. That was one of the factors. No. So that's like some rational function stuff going on there. And you got a remainder of minus 4, x squared minus 5 times x minus 2 is 4. All right, so let's try that. Okay. So x what was it, minus 2 divides into this polynomial. So again, we start off the same way. Do an x squared here, x cubed minus 2x squared minus, and look what happens. You get total cancellation, so you get 0 minus 5x plus 6. So multiplying by an x term will give me an x squared somehow, and I don't want that. So let's just plus 0 there. And now we need to cancel that at minus 5x. So now we do minus 5. Oops. Minus 5x plus 10. Cancel that. Those things cancel. You get minus 10 plus 6, or minus 4. So, yes. So x squared minus 5 times x minus 3, and then minus 4. So if you do this out in a grid fashion, x squared 0 minus 5 and x and minus 3. I just put in the 0x because ideally it reduces errors. Minus 3x squared, 0, 0, minus 5x plus 15. Right, so you have x cubed minus 3x squared minus 5x plus 15. Oh, sorry. Jeez. Goodness gracious. All right, that's a minus 2. That should be a minus 2. Okay. Whatever. And so you almost have the right polynomial, but now you need to subtract 4, and then you get what you want. Okay. So that's kind of the meaning of a remainder. It's the leftover bit. So you've got the thing you're dividing by, and you multiply it by the quotient, and you should get the thing that you're dividing into. But if you have a remainder, you have to add that remainder in, and then you got the equality. So it's like almost like this. It's the best you can do to get that form. And then there's that. Yeah, okay. So there's that. I guess I could say that in this form, you could think of graphing like x squared minus 5 times x minus 2. So it's going to have zeros at plus or minus root 5 and at 2. So you can kind of graph that out, and then you just shift it down by 4. All right, and so you don't really quite know too much, but you do know a bit of the waviness. So yeah, I would expect, yeah, I mean, I don't know. Anyway, I don't want to get distracted, but so that's kind of how you do long division. One can do more examples of these things, but it's, admittedly not something that one does except when one is talking about this topic. There is another technique called synthetic division, which is actually pretty quick and does a lot for you all at once. And so we'll talk about that technique. And that's the technique probably to get good at. The long division is just sort of a stepping stone to that.